Hey guys, just wanted to check in first. So sorry about not having the notes up or the practice sheet. My fault. I wanted to check in, make sure that you know that I'm alive, kicking. This is where I'm staying. That's the Pacific Ocean. Pretty sweet. So anyway, missing you guys. Hope you're doing great. And today what you're going to do is watch a quick video about the configuration around a chiral carbon. Is it an S or is it an R? And what that does is it tells the reader if we have a hash or a wedge and in what direction that's going to be. So hope you guys are doing great. Can't wait to see you guys next week. Today we're going to talk about R and S classifications for chiral carbons. And what that basically is saying that we are going to be able to tell someone through the naming of our compound whether or not certain components are on the hash or the wedge. So we're talking more details and being more specific about our stereochemistry. So it comes down to these letters. So R in Latin means rectus, or it's the right, which makes it very easy for us because R and right. S in Latin, it comes from the word sinister, which means left. So we're going to be going to the left or to the right. And how we do that, we're going to be doing it in a clockwise or counterclockwise circle. So are we going left or are we going right? And based on that, we're going to be running into different components on the zigzag where they are located. So we're going to take a look at that right now. So here is the priority, and it's really, really straightforward. Okay? The priority is first, if there is an element of any kind that is all by itself, we're going to take the higher atomic number as the priority. So that's kind of by mass, but it's by the highest atomic number. I'll show you that in a little while, but here's some examples. Like a halogen is always greater than an oxygen, greater than a nitrogen, carbon, hydrogen. So let's just say it's the halogen of number 17 chlorine versus 8 versus 7 versus 6 versus 1 for atomic numbers. Second one is carbon with an attached heteroatom. All right, so it has a carbon already attached to your chiral carbon, but that carbon has a heteroatom on it. And a heteroatom is any non-metal not carbon or hydrogen. And then lastly, if it's just carbons with hydrogens, then what we're going to be doing is if the carbon has less hydrogens, a little more, or the most, that is the priority. Okay? So that is how we're going to do this. Now, if you go off of your chiral carbon and there is a tie, in case of a tie, what you're going to do is you're going to have to walk down the chain until you find a difference. And you're going to do that one carbon at a time. And I'm going to show you that. So instead of going through these examples that are unclear and confusing, I want to go back to some of the examples that we've done in the past. So this is what we're going to do. We're going to use this rule right here, number 4. Okay? This is how we can make this really simple for ourselves. So what we're going to do is the lowest priority, which is going to be our number 4, because there's 4 components off of a chiral carbon, and that's usually your H. We're going to say that that is in the back or in the hash spot. And then what you do is you're going to trace from 1, 2, and 3. And again, I'll show this to you in a minute. And then if it's clockwise, it's R. Okay, and if it's counterclockwise, it's S. So I like to think of clockwise is going to the right, which is R, to the right. It's going counterclockwise, is going to be going to the left. This other one that is stated, the difference is, and all I'm going to do is highlight the difference, that this is in the wedge position. So what it's going to be is the exact opposites. So I'll explain that in a moment. So we're going to jump right into some examples, and we're going to go backwards to problems that we did in our notes from the other day. So I'm not sure if I actually did this one or not, but I have 4 different components, Br, H, Cl, and CH3. So that is a prime definition of something that is chiral. Okay? So if it's chiral, I can assign an R or an S. So let's talk about our priorities one more time, and I'm going to kind of copy and paste this around as I go. So the priorities, simply put, an element will always be number 1. Number 2, any kind of heteroatom or heteroelement. And lastly, as always, if we start having just carbons, we're going to take the more substituted carbons as we go. So what does this all mean? Well, this is how this works. First, my H is in a wedge position. It is in the back. That is ideal for us. That gets a number 4. Our goal is number 1, 2, 3, and 4. So now let's just look at what we have here. Bromine, you're never going to do this normally, is on the periodic table. I believe I have a periodic table in front of me. Number 37. If not, you know what? That's not right. I think it's number 35 off the top of my head. Chlorine is number 17. So because this is a greater charge or a greater atomic number, that gets the 1 and this gets the 2. Why? Because these are both elements. Finally, this one is just a carbon. It is sitting right here, but this is already the 4 because that's the lowest priority, and the other ones are elements, so this gets a 3. So now what you're going to do is you're going to ignore the 4. And what you're going to do is you're going to number. So where does the 1? If this was a 2 and this was a 3, I would draw an arrow this way. Because what I'm trying to do is go through my 1, 2s, and 3s. But in this case, I start at 1, and I'm going to wheel around through 2 and 3. Okay? So because that is going to the right, and this is in the back, that is a definition of a configuration of an R chiral carbon. Okay? That's an R chiral carbon. So I would like to do some more of those. So we're going to come down here to the ones that I did not work on yet. It says identify each stereochemistry with an asterisk. Then classify the configuration of each stereo center as R or S. So first let's grab this. Add this down here. So once again, I go to my hydrogen right away. Ooh, okay, so let's talk about this one. That's not good. I want to have my H's coming at me or going away from me. Okay? So what I need to do is I need to reconfigure this one. So what I want to do is I will want to switch this. This is a bigger problem than I was hoping for. We're going to skip that one first. Let's go to letter B. Okay, so here's my H. It always gets a 4. Okay, this is a chiral center. Why? Because I have an OH here, an H, a bunch of carbons, and a different looking path. So this illustrates this very well. So this is a heteroatom, and it's not connected to any carbon, so that's going to be a 1. So now this is where we need to start learning some things. This is a CH2, and what is this? This is a CH. If you would draw out your H's, there'd be 2 H's off of here, there'd only be 1 here. So because of that, this gets my 2, this gets my 3. Because according to my rules, carbons with less H's get the priority. So now, I am ignoring the H for the moment, and I'm drawing my direction. My direction goes from 1 to 2 to 3. I always draw it a little bit past. Now here's the issue. It is a wedge. So when it's a hash, and I go to the right, and what I'm talking about is the lowest priority. When it's a wedge and I go to the right, it's an R. So what you need to tell yourself, if I just messed that up, when it's a hash and I go to the right, it's an R. So this is a wedge, so it's going to be the opposite, and it's an S. And that is in rule number 5, where when H is a wedge, clockwise is an S. I don't like to memorize that. I just like to think, hey, H, I'm going to put it in the back. Okay, clockwise is R, counterclockwise is S, and if the H is in the wedge form, I will just flip these when I'm done. Okay, so this is an S. Let's take a look at the next one. So this is tricky. So let's talk about this. This carbon right here. Okay, I have a CH2, a CH2. This is just the C, and this is a CH2. So when I'm talking about if this is chiral or not, I know that it is because this path right here is a CH2 and that's a C with very different elements bonded to it. So there are 4 different components to this. Well, so is the case here. There's one here, there's one here. This is different than this path. So these are both chiral carbons. So I'm going to do one at a time. So I give my H's a 4. Okay. The next I do is any element that's by itself. So here right now is I have a Br here. I have a carbon with other items on it, or I have a CH2. So hopefully you think the element gets the 1. Now, will the CH2 or this carbon get it? Well, this carbon has a CH3 on it, but more importantly, this carbon has a heteroatom attached to it. So this will get the 3, and this line representing that direction will get a 4. So if I take my value and I skip the number 4, and I just said that wrong, this is the 2, oh, this is the 3. So I go from 1 to 2 to 3. The H is in the back, and I'm going to the right. I'm going clockwise. So this chirocarbon up here is an R. Now I'm going to erase just this number because it's going to be confusing otherwise. Now we do the other way. So this is going to be a 4. All right, this carbon is bonded to a Br, while this carbon is bonded to a CH2, and I have the OH directly bonded to the carbon. So although this Br is greater than the O, it's bonded to a C. This is directly bonded to the chiral carbon. So this will be the 1, which means this will be the 2, and this will be the 3. Priority: element, carbon with a heteroatom, and then just carbons. So now if I take 1 to 2 to 3, H is in the back, I'm going counterclockwise, so this chiral carbon is an S. All right, this is not a chiral carbon because there's only 3 clouds. So now, are these other ones chiral carbons? Well, I have a C, a CH3 over here, and that's not a CH3. So this is definitely a chiral carbon. A little star, and so is this. The reason why, guys, you can just easily look at this. These 2 are different, and then this pathway is different than this pathway. So they're both chiral carbons. So once again, we assign the H a 4, and then we start having to look. So this carbon is directly bonded to an N, so this will get a 1. Then I'm going to go this way. This is a CH3. This is a CH with an O on it. So this will get a 2 because of the oxygen. This will get a 3. And now I skip the hydrogen, the number 4. I go 1, 2, 1, 2, 3. I'm going clockwise. So clockwise is an R, but you go, oh wait, H is a wedge, not a hash. So this gets an S. Taking a look at the other one. This would be a 1. Again, guys, I'm looking at these spots right here. Only these lines coming off that carbon. The H will always be a 4. And now, what do I have here? I have a C double bonded to an O. Here I have a CH double bonded to an N. So there's a lot of things you can look at this, but this has less H's on it, and it also has an O that is a higher atomic number. So this will be 2, this will be 3, this part will be the 3. So I have 1, 2, and 3. I want to go in this path. So I'm going left, so that is usually an S, and then, oh, the H is in the back, so that stays an S. So that is another sinister. Okay. So this last one, this one's a tricky one. And the reason why, excuse me, this last one's a tricky one. And the reason why is that we need to flip some items. Okay, we need to get the enantiomer. So what I need to do is actually get my H or my Cl in O hash or wedge, or my H. So I'm gonna flip these right here. I'm gonna flip these two. So if I do that, now I have Br here, still have F, now I have my H coming out, and I still have my Cl going like this. So this is an enantiomer that's opposite. Okay, so now if I assign this, and this was by far the hardest one, my H gets a 4. So now what are we doing here? Br has the highest atomic number, so 1, Cl has the next, that's 2, this is 3. So we draw from 1 to 2 to 3, we skip the 4, and I go like that. So this is a wedge, I'm going to the left. So normally left is S, this is a wedge, so this is an R. But because I flipped it, everything flips. So my actual compound, the one that matters, is an S. We'll talk about that more later, but you have to find this in terms of having an H in a hash or a wedge. So you have to change the configuration, but because of that, I changed it into an enantiomer. And the enantiomer is a mirror image, but different. So when I flip it back the other way, it will cause my R and my S's to switch. So what you just learned right now, that I haven't actually officially said, is any enantiomer that you have, one is an S and one is an R. Okay? And I want to prove that before we move on to our last problem. So I'm going to come up here, I'm going to find one that is an enantiomer. So right here. Now I need to find one that has H's. Here we go. We'll do this one. So I'm on letter B above. So this will kind of show how this works. So H will be the 4, O will be the 1, as always. Okay, so how does this work? This is a CH3, and this is a CH2. So the CH2 will always win out on that. So this is the 2, this is the 3. So I go 1 to 2 to 3, and the H is in the back, and I'm going to the right. So that is an R. So in theory, guys, this should be an S, but let me prove it. So my H is my 4, my O is my 1, and I have CH3 here and a CH2 here. So this will be the 2, this will be the 3. So then I go 1, 2, 3, and this time the H is still in the back. Now I'm going to the left. So yep, there it is. So enantiomers, one is an R and one is always an S. So finally, last little problem, and then we'll look at our worksheet. It's at the bottom of the note sheet. It says draw a R3 chloroheptane. All right, so there are many ways to do this, but I think this is the easiest way that you can, okay? That I say just draw. Just draw it, okay? Okay, what do I mean by that? So, okay, there's 7 C's, so 1, 2, 3, 4, 5, 6, 7, okay? And then on the third carbon, there's a chlorine. So what I'm gonna do is just, on the third carbon, I'm gonna cause the chlorine to come out. That means there's an H going away. I don't know if this is right or not. I'm just setting it there, okay? So this is a chiral carbon. And the reason why, again, is I have 4 different attachments to that carbon. So what would I do here? Well, I would cause my chlorine to be 1, my hydrogen to be 4. So now, here's where it's talking about step by step. This is a CH2, this is a CH2. This is a CH3, this is another CH2. So as I step down, these are equal, but then I go to here, that's the winner. So because of that, that has to become my 2. This becomes my 3. So when I wrap this around from my number 1 to my number 3, I put the wedge on the back because I want to do that. This right now going to the left is an S. Shoot, I want an R. So the easy way to do that is, if you get lucky, fantastic. Otherwise, all we do is we redraw it, or you erase it, and then what do you think you're going to do? You flip your stereochemistry. So now, instead of my chlorine coming at me, it's going away from me. It doesn't matter that it's here or here. And my H was going away from me, now it's coming at me. And this, if you want to prove it, it already works, but this is going to be this is my 1, this is my 2, and my 3, and I'm going that way. So I'm going to the left, but this is coming at me, so it becomes an R. Okay? So let's take a look at our note sheets, or our practice sheet, and see what we got here. All right, so this is Stereochemistry 2, and what I would do first is to make sure you write down our priorities. So basically we have element, carbon with a heteroatom, or just less C's or less H's on our C's to more H's on our C's. Okay? So I'm going to pick this one right off the bat, number 2. We'll do number 1 and number 2. Well, they're actually really similar. Let's just do number 2. So I always take my hydrogen and say that's 4, any element number 1. Okay? So then again, what you need to think about is what you're seeing. So this is a CH3, this is a CH2. And according to our priority, CH2s get the priority over CH3s. So that means that my CH2 is my 2, and this is my 3. And then all I do is I ignore the 4. So I go 1, 2, and 3. So I'm going clockwise, so that's normally an R. I always just tell myself right away, it's an R. Oh, but the H is coming at me. So because the H is coming at me, it's opposite. So that is an S. Okay? Let's drop right down below. Right away. This H is a 4. The O is the 1 because it's a heteroatom. Okay? So now what we got to think about is what we're seeing. What we're seeing is this. This is a CH2. And what is this? This is a CH. If you look at that, there's already 3 bonds to it. So that, you guys, would be the 2, and this is the 3. So then I take my 1 to my 2 to my 3. I'm going clockwise. So I always think R, and this time that the H is on a wedge. So this is still R. So that's how that one works. Okay, so as you're continuing on through this, please look at the hierarchy and make sure you give the H a 4 immediately, and then try to figure out your 1, 2, and 3. Get a clockwise or counterclockwise swirl basically on this, and then if the H is in the back, then it's straightforward. R is to the right, S is to the left. If the H is as a wedge, then you need to flip it.